Alright, this problem is about scores on an English proficiency test, and there's concern about difference between boys and girls, and the school board brings in a motivational lecture so that boys will be motivated to study harder. Okay, so I'm going to see what the data look like by pressing enter. Alright, so we have 85 girls, 84 boys. These are the frequency histograms for both groups. The data don't look skewed. They look pretty unimodal and fairly symmetrical. How many groups are there? There are two groups. Other groups naturally defined or experimenter defined. They are naturally defined, as gender often is. Well, always is. Are the two groups independent, or are subjects in group 1 matched to those in group 2? They are independent. They're different subjects. They weren't matched with respect to any characteristic. Okay. Are the measures independent? Yes or no. The measures are independent as well. Are the measures continuous or binary? It's scores on some sort of test, so they are continuous. How many measures are there per subject? One. Is there a reason to believe that the sample means will be normally distributed? Because the number of individuals in each group is so high, 85 and 84, and because based on these histograms, there's reason to believe that the data are normally distributed in the population. We know that the sample mean will be normally distributed because of the central limit theorem. Do we know the population standard deviation for the subjects in group 1 and in group 2? Well, let's see. These are the population means, 75 and 61, and these are the population standard deviations. So the answer is that yes, we do know these values. Enter the sample mean for group 1, round to 4 decimal places. So to get the sample mean, just take this value, sum of x's in group 1, divided by the number of scores in group 1, 63, 63.9 divided by 85, and round to 4 decimal places, so 74.8694. Alright, sample mean for group 2, same procedure, so it's okay. Is the population standard deviation of the difference between the sample means known, or does it have to be estimated? Because we have the population standard deviation for each group, we can just compute the population standard deviation of the difference. So we don't have to estimate it. We can know it as fast as, or as soon as we compute it. So it is known. What is the population standard deviation of the sample mean for group 1? It's simply the population standard deviation for girls, that's group 1, divided by the square root of 85, which is the sample size. So let's see what this value was. Okay, so 4.5 divided by square root of 85. 4.5 divided by square root of 85. Okay, we have to round this to 5 decimal places. Alright, so that's 4.48809. Okay, so that's 1, 2, 3, 4. Alright. Same thing for the second group, so let's see what their population standard deviation was. It's 5.1 divided by the square root of 84. Okay. Alright, now, what is the population standard deviation of the difference between sample means? You can either refer to the formula, or what you could also do is square each of these two values that you just computed add them together and take the square root of the sum. So I'm going to square 0.48809, add it to 0.55646 squared, take the square root of that value, and round to 4 decimal places, so 0.7402. And that's correct. Okay. What statistical test should you use? In this case, we have two independent groups. So the tests you've learned are the Z-test and the T-test. So that's either A or B. Because you know the population standard deviations and you don't have to estimate these for the population or for the standard deviation of the mean difference, you can use the Z-test. So the answer is A. Alright, what is the expected value of the population mean difference between the two groups under the null hypothesis? We can go back and see what the difference was between these two groups when the null is correct. So 75 for girls, 61 for boys. So 75 minus 61, 14. Okay. Okay. Which research hypothesis is appropriate? If the motivational lecture works, the difference between boys and girls should be smaller. Okay? Not larger as B would suggest, or simply different as C would suggest. So go with A. Enter the value of the test statistic, round to 2 decimal places. So now you have to compute the z-score. So I'm just going to do that here. So again, if you remember the way this works, just take the difference between the sample means. So I'm going to compute the difference between 74.8694 and 68.5321. So 74.8694 minus 68.5321. Okay. And I will subtract from that the difference between the population means, which is 14, and divide by the standard deviation of the difference between sample means, which is 0.7402. Alright, and the value I get is minus 10.35. Minus 10.35. My fingers are crossed. Okay. The test statistic value corresponding to the lower boundary of the acceptance region. Okay, so because my research hypothesis is that the difference between the population means after the motivational speech is less than what it is currently, my rejection region is in the lower tail, and let's see what alpha I was told to use. Use alpha 0.01. Okay. Because of that, the lower boundary of my acceptance region corresponds to a z-score, the z-score corresponding to an area, the shaded area being 0.99. Okay, so let's see what that is. Okay, so this is the z-score, and it's a one-tailed test. And of course it's negative. You don't want to get an error for forgetting that. Alright, enter the test statistic value corresponding to the upper boundary of the acceptance region. So the upper boundary is going to be infinity. Okay. Alright, so that's the acceptance region. Do we accept or reject the null hypothesis? Because the value of z we got was minus 10.35, it clearly falls outside of the acceptance region, so we reject the null hypothesis.